This is a paragraph type question that appeared in JEE Advanced 2018. So this is from the topic permutations and combinations. So let us go through the question and solve it. But before going through the solution, I would strongly recommend you to pause the video and give it a try. There are 5 students S1, S2, S3, S4, S5 in music class, and for them there are 5 seats R1, R2, R3, R4, R5, S1, S2, S3, S4, S5, and there are 5 seats R1, R2, R3, where initially the seat Ri is allotted to student Si. So R1, R2, R3, R4, R5. So the seats are allotted like this initially. But on the examination day, the 5 students are randomly allotted 5 seats. The probability that on the examination day, the student S1 gets previously allotted seat. So S1 gets the previously allotted seat R1, and none of the remaining students get the previously allotted seat. So S2 should not get R2, S3 should not get R3, S4 should not get R4, S5 should not get R5. So this is the condition. S1 should not get R2, S3 should not get R3, S4 should not get R4, S5 should not get R5. So this looks something like a famous letter and envelope problem. Letter and envelope problem. So let us say there are letters L1, L2, L3 and envelopes E1, E2, E3. So this first letter should not go into the right envelope. It can go to any other envelope. Similarly, second letter should not go to the envelope E2. So it is that problem. So S1 can go to R1. So this can happen in one way. So this is the famous letter and envelope problem. So S2 should not go to R2 but can go to any of R3, R4, R5. So this kind of arrangement is called derangement. So if there are n letters and n envelopes, number of derangements, so number of such arrangements, this kind of arrangement is called derangement. Number of derangements will be n factorial times 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus and so on plus 1 by n factorial. This is the formula to find derangements. Now the probability, so we are asked about the probability of this event happening. So in this case n will be 4. So S1 will go to R1. This can happen in only one way. We have to find out how many ways in which this derangements can happen. So that will be 4 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial. So this and this gets cancelled. So 4 factorial by 2 factorial, that is 24 by 2, 12, minus 4 factorial by 3 factorial, 4, plus 4 factorial by 4 factorial, 1. So 13 minus 4, so that is 9. So total number of ways of seating arrangements will be 5 factorial. Anybody can go to any seat and that can be done in 5 factorial ways. So probability will be 9 by 5 factorial. So that is 9 by 120. That is 3 by 40. So the probability is 3 by 40. That is option A. So let us go ahead and solve the second part of this question. This is the second part of the question. For I is equals to 1, 2, 3, 4, I is equal to 1, 2, 3, 4, Ti denote the event that the students S1 and Si and Si plus 1 do not sit adjacent to each other on the day of examination. So T1 is S1 and S2 are not adjacent. So T2 says S2 and S3 are not adjacent. T3 is S3 and S4 are not adjacent. T4 says S4 and S5 are not adjacent. So we have to find the probability of T1 intersection, T2 intersection, T3 intersection, T4. So all these events should happen. So what is the probability that all these events happens? So total number of seating arrangements will be 5 factorial. Total number of seating arrangements will be 5 factorial. Correct? So now let us find out the number of ways in which this can happen. So let us divide the problem into 5 cases. Case 1, case 2, case 3, case 4 and case 5. So let us consider S1 as 1, S2 as 2, S3 as 3 and S4 as 4, S5 as 5. So if 1 is in the beginning, 2, 3, 4, 5. If 1 is in the beginning, the next seat can only be occupied by 3, 4 or 5. 3, 4 or 5. So 3 is here, so next seat cannot be 2, it can be 4, it cannot be 4 also, it should be 5. This is 5, so the next seat should not be 4, so this has to be 2. So the next seat is 4. Next, this is 4, so next seat cannot be 5, next seat cannot be 3, so this has to be 2. So next seat, this is 2, the next seat cannot be 3, so this has to be 5, and this is 3. So this is 5, so the next seat cannot be 4, so it can be 3, or the next seat can be 2. This is 3, the next seat cannot be 2, it cannot be 4, so this case is not valid. So if this is 2, the next seat cannot be 3, so this can only be 4. But if this is 4, the next seat cannot be 3, so this case is also not valid. So let us go ahead with the second case. If this is 2, the next seat cannot be 1 and it cannot be 3, so it can either be 4 or 5. If this is 4, the next seat cannot be 3 or 5, so this has to be 1. If this is 1, the next seat can be anything, 3 or 5. So let us say 3, and it can be 5. But if this is 3, this has to be 5. If this is 5, this has to be 3. So now let us go to this. If this is 5, next seat cannot be 4, it can be 3, or it can be 1. Yes. So if this is 3, next seat cannot be 4, so it has to be 1. This is 1, the next seat is 4. If this is 1, the next seat can be 3, or it can be 4 as well. 2, 5, 1, 4. So but if this is 3, this cannot be 4, so this case is not valid. If this is 4, this cannot be 3. So this case is not valid. Now let us go ahead. So if this is 3, this cannot be 2 or 4. So that can be 1 or 5. But if this is 1, the next one cannot be 2. It can be 4 or 5. But if this is 4, next one can be only 2. This is 5. If this is 5, the next one can be only 2 and this is 4. If this is 5, the next cannot be 4. It can be 2 or it can be 1. If this is 2, the next should be 4. This should be 1. If this is 1, the next should be 4 and the next one should be 2. So proceeding to the next case, if this is 4, this cannot be 3 or 5, so it can be 1 or it can be 2. So if this is 1, the next case cannot be 2, so it can be 3 or 5. If this is 3, the next case cannot be 2, so it should be 5. This should be 2. If this is 5, the next one can be 2 or that can be 3. But if this is 2, the next one cannot be 3, so this case is not valid. If this is 3, next one cannot be 2, so this case is also not valid. If this is 2, the next one cannot be 1 or 3, so this has to be 5. And if this is 5, the next seat can be 1 or 3. If this is 1, this can be 3. If this is 3, this can be 1. So moving ahead with the last case, if this is 5, this cannot be 4. It can be 3 or it can be 2 or it can be 1. If this is 3, the next one cannot be 4 or 2. So this has to be 1. If this is 1, the next one cannot be 2. So this has to be 4. This is 2. If this is 2, the next one cannot be 1 or 3. So this has to be 4. If this is 4, the next one cannot be 3. So it is 1. This is 3. Similarly, if this is 1, the next one cannot be 2. So this can be 3 or 4. If this is 3, the next one cannot be 2 and cannot be 4. So this case is not valid. If this is 4, the next one cannot be 3. So it has to be 2. But if this is 2, the next one cannot be 3. So this case is also not valid. So the total number of valid cases are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So probability is equals to 14 by 120. So that will be 7 by 60. 7 by 60. Option C. So it is a lengthy problem. So you have to do it by cases.